Hi guys, and welcome back to another multi-time tutorial. So in this tutorial, we are going to be designing a two cavity two plate mode for a dustpan, and we are going to be designing the mode all the way from start to finish. So join me as we learn how to design how you can easily design modes in Fusion all the way from start to finish using the help of AIG mode wizard, the Fusion add-in. So for this mode, we've got the paths, then we've created the coding line, the gate, and the ejector points, and also the runner and some other layer sketches and the cavity spool points. So let's get started. So before we start the mode design, we have to first start by validating our paths. We have to check if the thing was designed perfectly and optimized for injection molding. So you can validate the parts still in the design workspace by using the Fusion Plastic Design extension. It's a very good tool. So I think let's hide all this one. Hide this, and leave only the parts because we've already assigned a plastic tool. This is not necessarily going to be APS, but it might be PP, but let's just use APS. So what we need is really the design parameters. So I'll do this one. So first we select the paths, then the pull direction is upwards this way. So let's analyze the body. And so we've done analyzing the body now. Our undercut is okay. We have a few areas with straps, just very few straps insufficiency. Then our knife edges, well, we don't have enough edges, so it's okay. Then thickness, just the very few regions again. So now let's check for the thickness. So I prefer this view. So as you can see most of the areas are uniform. Is showing almost dark red, with almost red in color. Because the plastic rule we selected was 0.1 inches and this part is a bit bigger than 0.1 inches. So that's why most of the regions is appearing too thick. And it's because of the plastic rule we selected. But the major thing about the wall thickness is the uniformity. That's the most important thing. How uniform is the wall thickness. And for this one, we just have, as you can see, I've extended reduce the threshold. You can adjust to see the thickness variation here. You can adjust it here. So when you adjust it, this in inches. So let's bring it down. So this is the thickness variation. So if you minus 0.881 minus 0.07686, you can just see the thickness variation you have. So let's check if all the parts are open. Let's extend this a little bit. So to know, so let's go over to minus it here. So I've written our variation here. So now let's calculate the variation to know actual what thickness variation we have. Just see what we have here. So we have 0.881 minus 0.07438. So this is the thickness variation we have 0.0043. So in case if you want that part in mm, we can also convert that to as well. So over to inches 0.00443. Yeah, so we have 0.1 millimeter, 0.11 millimeter. So That's our thickness variation. So it's okay. It's quite okay. It's okay, but even if it's not perfect, but the wall thickness is still very, very uniform. So we're going to leave the wall thickness for now. So now let's check for the draft angle because we have some few regions with our drafts. Not seeing anything yet. It's going to highlight it in red. I can't, I can't see anything. I can't find anything. Let's just, you can click here to check the region, but still can't find where the draft region is. Yeah. So I think the draft angle as well, we are good to go. So, one thickness. So for these parts, I think we are good to go. So just a insufficient drafts, but can't really find anything. Yeah, let's try to find where it says insufficient draft, but I'm not seeing it as you see all this. If there was an area with insufficient draft, it's going to highlight it in red, but for now, I can't find anything. So let's just check the other mirror parts just to be sure. So we need to assign the plastic rule for this. Assign the same plastic rule as that's already ABS 0.1 inches. Select these components. Okay. Able to design advice. Flip, analyze. Thickness to the same thing. That always prefer the other view. Yeah, thickness to the same thing. Definitely to go up eventually. Yeah, so the thickness still the same. Let's go for drafts. Drafts, yeah. This area, we have some problem in this area, so we have to fix that. So now to fix that, we have to go to our design workspace back, or you can still remain the plastic menu anyways. So now you go to drafts, service, modify, drafts, full direction. Our full direction is this way. I change it. So select this area, this area, and this area. Uh, so because they are going to be opposing, so let's flip. We have to flip the full direction because this whole area is going to be one part. It's actually this way, but this is a pocket. Yeah, so it's the full direction is supposed to be the other way. Yeah, so that's added the draft. The draft angle, we don't need to put any value for the angle because it uses the plastic design rule to add the parameter. So it's okay. So now let's check it again. Select select the parts, flip, analyze, thickness, drafts. Also, you can see it's no longer highlighted in red, so that part is okay. So now we are done validating our parts. Our part is ready to go into the injection mode design process. So go to utilities. Now we have our AIG modes design add native. Also, you create a project first. To start the mode design, create a project first. You can Open this, drag this upward, and extend this to anywhere you want. As to company uh, let's just change it to DOS limited, put anything here. I can change this. It doesn't really matter. Like if you watch my previous video, what really matters is the project name and the project ID. Make sure make sure make sure you take them down, because if for example you want to start a new design, you create a new project, that project is going to be, you are going to be working on that new project. But if you want to come back to this new project and you want to continue, all you need just to do is just to create a new project and include the same project name and the same project ID. So it's going to update any new changes you add. So mode manufacturer, and just input any random thing here. Then this is your name. It's going to include the same name. Okay. So you have the message project created successfully. Okay. First start by trying to create the core for the class. So to do that, surface, the surface menu will be very helpful to us. So move over to surface, offsets, we offset this, move over to patches, patches. Okay, and also you can stitch those two together. Stitch this one. Okay, then stitch this one, stitch this one. Okay, so now we just have two single surfaces. So next, just like this, now I want to create to cover this front edge. Select the edge, hold down control, select this one over here. Okay, so now you can stitch them together. Stitch. Okay, so patch, complete patch. Just make sure the whole perimeter was selected. Okay, so now let's stitch them together as well. Yeah, okay, you can see it's created a solid body. So that's what fusion does. If you have a perfectly uh, enclosed boundary, a closed surface boundary, it automatically helps you to create the solid body. Don't know if it's everyone that likes that, but anyways, I like it. So now I'll cover this front again of the other mirror parts. Okay, let's stitch them together. Oh, let's see again. Patch everywhere and stitch them together. Okay, so now we have our two bodies created. So now we're going to create the cavity blocks. Set a rectangle. So now This should be 577, sorry, uh, 334, 5, 557, I mean. Then this should be 334, enter. Now you can hide this two button. Then if I should hide this as well because I don't want to cut them. Go for symmetric, 140 to then it should be 140 mm. You don't need everything else, so this should be new components. And let's inspect that 140 mm, 557, push repeated the correct parameters 334. So you can go. Well, let me split. When I split them first before we assign names to the cavity, now we can turn this back on. So let's do a section analysis to see how they have been created inside. Yeah, so this is what you have. So now you have to split this block by using our pattern line. We have to use our pattern line to be able to split this block. So now let's think this need to be on. So now we go to split body. This body we want to split, hide it. So this pattern line, this edge is going to be our pattern line because that's the most easiest for us. It's then split into yes. Okay, so let's on our body. Did we hide the other body? Uh, so there we have it. So this part one, and these are second parts. So you can see it. So these are two components. Now I don't want the two components. I don't want the two, if I just click this and to create components of body, there is some way it's going to be a sub-component of this one. So I don't want that. I want them to be two very separate offices. So now I'll go to the parent component and do new components. Name is later. Okay, so activated, turn this back on. So now which we have to know which are A parts and which should be our B parts. So these two will be our B parts. So now I just select this and dump it here. Yeah, so now they're now two separate entities. They are not tied together. Then now let's hide this one, then I think two bodies are on. Our parts are on as our part is the on as well. And that's my own parts. These are parts. So we have to combine these them together because this is going to be our core side, while the other side is going to be our cavity side. So my usual shortcut was spacebar, but the latest update of Intuition, they turned this to under thing here. If you hit spacebar, it goes to the previous command. It selects the previous command you've selected. So I don't need to keep this to be active because I need them to be together. Okay, so now we have our core sides and we turn this on. On this, first we have to create our cavity side as well. So now we hit spacebar, combine, still cut operation. So we select the two bodies, click choose OK. So do again the spacebar, select this one. We need keep choose to be active. Okay, now so let's check if we have our call. So now we have our cavity created as well. This is our cavity side. Turn over. This is our core side. Let's just do section analysis and make sure that everything is okay. And I think, yeah, that's the parts. Hide the parts. Uh, the parts created there and views from this side as well. Uh, so we have our core and our cavity piece ready. So can go over and remain them. So we call this cavity plate A. Then we call this cavity as cavity plate B. So we have our core and cavity plates ready. So next step is to create our mode base. Yeah, so let's start creating a mode base. So go back to our utilities menu to access our AIG mode wizard. So we'll be using Haskell mode basis. We need cutouts. So our plate C type will be a K45 or mode basis of size 646 times 646 or 8 thickness 136, bit thickness same thing. Uh, riser height 126. Okay, now wait for it to do its computation. We have it here. We have our mode base here already. So let's check if everything was created properly, meaning if the A plate is actually on the side that's supposed to be on the A plate and the B side that's supposed to be on the side that's on the B sides on the B side, and if the cavity A plate is supposed to be on the A plate side, and everything seems fine. Everything is fine. So now let's start creating our cuts to hide all these sides. Let's create the pocket first for the A plates. Uh, interferes with this a little bit, so we're going to cut everything and we hide let's start with the B plates. So We have to cut them together. So let's our components is power is components as on. So big for combine. So we need this body of that selected. This body. Make sure keep to this active and the components as well. Okay. So now let's hide everything to see if yeah. So our gets has been created for the A side. So now let's do for the B side as well. And hide this, then we just need to do the giblets. No need for the rest. Again, you can hit spacebar or my shortcut B. So let this one, then they put this as well. Yeah. Okay. Let's hide them again and see what we got. Yeah. So I now have the pockets for the A side and the B side. You can just do a section analysis to see if we're having any interference or anything. That's really supposed to be for the patch, just so you know. So a good distance away from the guide elements and so on and so forth. Yeah, so we have our crown cavity complete and our mode base is ready. So we're going to do the same way as we did it before. We start from the we finish up with the injection side, then we come over to the injection side. So in our next video, we are going to start working on the injection side. On the injection side, we finish the work on the guide elements, all the screws and the cooling lines and the injection system before we move over to the injection side. Okay.